Out of all of the planets in the solar system, all top 5 of the tallest mountains are located on Mars, and the majority of them are clustered on only a particular patch of Mars, which is around the equator. That region is called Tharsis. At around 20 million kilometers square, it is about the size of South America, and it is about 6 to 7 kilometers high, meaning that elevated terrain is only by around 2 kilometers lower than the height of Mount Everest, the tallest mountain on Earth. This region is characterized by a distinct lack of craters. Compared to most of the surface on Mars, on Tharsis, there are parts that go on for many hundreds of kilometers without a single significant crater. And perhaps the most weird thing about Tharsis are the 3 nearly perfectly lined up volcano shields that are also spaced evenly. There is a space of about 700 kilometers between the top of each volcano. One solution to how this formed says that Mars in the past had a hotspot, which made it such that as the plate above moved, which is independent of the hotspot, it created a chain of volcano shields. On Earth, such a thing can be observed on the Hawaiian Islands, which are actually chain volcanoes that were created in such a way. The largest, Hawaii Island, is the most recent one, forming about 500,000 years ago. And as we move northwest, the islands are progressively older. If this situation is also true for Mars, then that also means that depending on what direction the plates were moving on Mars, it's either Ascarius Mons, that is the oldest of the 3, or Arsia Mons. Whatever the case is, we know that Pavonis Mons, which is in the middle, is between the age of Ascarius and Arsia. By height, of the 3 volcanoes, Ascarius Mons is the tallest, at 18.2 kilometers, which also makes it the second tallest on Mars, and the second tallest planetary mountain in the solar system. Then at the 3rd place, on the other side, there is Arsia Mons, at 17.8 kilometers. And at 4th place, between Ascarius and Arsia, there is Pavonis Mons, at 14.3 kilometers. Now, these volcanoes are by around 2 times taller than Mount Everest, the tallest mountain on Earth. However, to some it might seem like that is not a fair comparison, as on Earth, Mauna Kea on the Hawaii Island, from the seafloor to the top is 10 kilometers in height. So, if we measure the height of volcanoes by how much they are above the surrounding plains, then Mauna Kea actually comes up at around the same height as Pavonis Mons, because Pavonis Mons is around 8 kilometers above the surrounding plains, and Arsia Mons is about 10 kilometers above the surrounding plains. Ascarius Mons still comes up way taller than Mauna Kea, as it is about 15 kilometers above the surrounding plains. However, there is a slight problem with the Mauna Kea comparison. Mountains on Earth aren't measured by how much they are above the surrounding plains, because a lot of the times it's hard to tell what part can be considered a part of the mountain and what can be considered a part of the surrounding plains. So that way we don't have an exactly defined way of where to start measuring, meaning it's not a very objective way of measuring height. Because of that, something a lot more neat and objective is used to measure the height of mountains on Earth. And that is the sea level, which is nearly the same everywhere, and thus is used as a reference point for the height of all of the mountains on Earth. On top of that, measuring from the sea level conforms much more closely to the amount of the atmospheric pressure, compared to measuring them from the surrounding plains. Therefore, Mauna Kea, with the objective reference point, which is the sea level, is actually 4.2 kilometers tall. And with that, its air pressure at the top is around 0.6 bars, while on Mount Everest, at the top, it's 0.3 bars. Also, the pressure at the sea level is 1 bar. Mars, just like the Earth, also has something akin to the sea level, and that is the datum. Datum incorporates gravitational plus rotational potential of Mars to create the 0-meter reference point. So the height of mountains on Mars isn't measured by how much they are above the surrounding plains, or through taking the deepest point on Mars as a reference. Rather, it's through the datum. And measuring with the datum, just like with the sea level, also conforms much more closely to the amount of the atmospheric pressure. Now, the lowest point on Mars is in Hellas Planitia, at 8 kilometers of depth, and taken together with the height of the top 5 of the tallest mountains on Mars, that makes them all between 22 to 30 kilometers tall. Meaning that even then, they are still a lot taller than Mount Everest, taken together with the depth of Mariana Trench, the deepest spot on Earth, which has a depth of 11 kilometers. And taking that depth together with the height of Mount Everest makes Mount Everest 20 kilometers tall. Now, although Asclepius Mons is taller than other 2 volcanoes, they are all still about the same size surface-wise. They are 150,000 kilometers square, which is about half the size of Italy. Asclepius Mons, compared to the rest of the surface, has a high level of reflectivity, which is the case for most of the high elevations on Mars. That is caused because of a thick buildup of reflective Martian soil. The buildup is also much greater than on the rest of the surface, because at high elevations, such as on Asclepius, the air pressure is much lower, causing winds to be much weaker and unable to clean the dust off. The pressure at the top of Asclepius is 100 pascals. Meanwhile, the average pressure on Mars is 600 pascals. Despite being so tall, the height change in Asclepius from top to bottom is rather gradual overall. However, despite the average slope of Asclepius Mons being only 7 degrees, that is still above average in terms of steepness for volcanoes on Mars. At certain spots, Asclepius is filled with these fractures which actually have vents that allow for the lava to spread on the surface. At the top of Asclepius, there is also a complex of several calderas overlapping each other. A caldera is a formation that occurs on certain volcanoes when a large amount of lava is dispatched over a short period of time. Because that leaves empty space below, the surface collapses and forms a crater. The central caldera of Asclepius is about 30 kilometers in diameter and is 3 kilometers deep, and the rim of the caldera looks like this. Crater density indicates that it is about 100 million years old. Other calderas can be dated back from 800 million to nearly 4 billion years old. Considering that Mars is 4.5 billion years old, that means that Asclepius was active during most of the existence of Mars. Pavonis Mons is the central volcano. It is also very dusty and has lots of fissures, but on Pavonis, the fissures create a pronounced circular pattern. Its central caldera is about 45 kilometers wide and nearly 5 kilometers deep. This is how the immense cliff at the rim of the caldera looks like. Beyond the central caldera, there is seemingly another one. It is not as deep, and it's quite eroded. There are also indications that Pavonis had and even still has glaciers. Next, and the last of the 3 Tharsis Mountains, is Arsia Mons, a volcano surrounded by terrain at about 7 to 8 kilometers in height. Arsia is characterized by its enormous caldera. It stands out even among the rest of the volcanoes. It is 120 kilometers in diameter. Even the caldera of Olympus Mons, the tallest planetary mountain in the solar system, has a caldera that is about 70 kilometers in diameter. It is way smaller than the caldera of Arsia. The surface area that the caldera of Arsia covers is about 12,000 kilometers square. That alone is larger than quite a few countries on Earth. This is how the edge of the caldera looks like. Standing near it, in the distance, you would see the vast flat floor. And maybe, just barely, you would be able to make out the rim of the other side of the caldera. Directly on Arsia Mons, and slightly around it, 7 possible cave entrances were found, ranging in size from 250 to 125 meters in diameter. Their low change in temperature and darkness indicates that they are cave entrances, although it's possible that they are just really deep pits. Whatever the case is, they are at least 180 meters deep. During each spring on Mars, a cloud around 1,000 kilometers long appears above the western slope of Arsia Mons. The details regarding how it forms are still not entirely certain. Now let's move on to Olympus Mons, the tallest planetary mountain in the solar system, located just a bit beyond the Tharsis region. It is 21.9 kilometers above the datum, so it is about 2.5 times taller than Mount Everest. Now Mauna Kea is about 10 kilometers above its surrounding plains, while Olympus Mons is a staggering 26 kilometers above the surrounding plains. Measured that way, it is also 2.5 times taller than Mauna Kea. On the edges of Olympus Mons, there are cliffs that go up to 8 kilometers in height. And beyond the cliffs, the slope of Olympus Mons leading to the top is so gradual that from many sides it is only about 5 degrees. On the way to the top of Olympus Mons, the terrain would look as if it is only slightly curved, almost flat. The size of Olympus Mons is 300,000 kilometers square. That is comparable to the size of Poland or Germany. It is also about the size of Arizona, meaning that it is larger than about 45 US states taken individually. Such an enormous size means that while being on Olympus Mons, on most parts of its surface, the volcano would entirely obscure the view of the rest of the Martian surface. It's not like a regular mountain where you get a nice view of everything below. The caldera at the top of Olympus Mons, although not the largest as mentioned, is still enormous, with a diameter of 70 kilometers and a depth of 3 kilometers. It's also actually a complex of calderas, and based on crater density, they are between 300 to 100 million years old. Unlike Ascrius, Pavonis, and Arsia Mons, which are found on the highly elevated Tharsis region, and unlike Olympus Mons, which is basically right next to the Tharsis region, Elysium Mons is way further away, around 5,000 kilometers away from the Tharsis region. Elysium Mons is the 5th tallest mountain at 14 kilometers above the datum, although it's also possible that it is the 4th tallest, as its height is very similar to Pavonis Mons. Elysium Mons is right next to Utopia Planitia, which is an enormous crater about 3,000 kilometers in diameter. However, today you can barely make out that it is a crater. Still, the topography confirms it. Now, the general region that Elysium Mons is in is a place where it is likely that the ancient ocean of Mars once was. As can clearly be seen with Elysium, it's hard to say where it begins, as it has a rather smooth transition. Still, this red region is where it's fair to say that it begins. This topographic map shows that it starts to pick up height quite a bit here. So that would make it about 50,000 kilometers square surface-wise. However, another interpretation could be that this very circular region is where Elysium Mons begins. It's pretty circular, the caldera is sort of centered, so it seems rather plausible. If so, then it is 500,000 kilometers square, which would actually make it close to 2 times the surface area of Olympus Mons. From near the top of Elysium Mons, because the height picks up suddenly in the red region, you would actually get a nice view of the surface below. You would get to see nearly 200 kilometers into the distance, which would allow you to just slightly see the curvature of Mars. At the top, there is also a caldera about 14 kilometers in diameter, so quite large, but pales in comparison to the calderas of the taller volcanoes. So all 5 of the tallest mountains on Mars and the solar system were covered. However, on Mars, there are other shorter volcanoes that are also very interesting. For example, Tharsis Tholus, located on the Tharsis Plateau. This volcano shield in general is the steepest one on Mars at 10 degrees. It is also about the height of Mount Everest at 9 kilometers, and it is ancient. Its western slope density indicates that it is about 3.8 billion years old. That slope is unusually steep for volcanoes on Mars. And right at the top of the western slope, there is an elevated patch of the rim of the caldera, which not only gives a nice view of the caldera that is 45 kilometers in diameter, but also of the plains below the entire volcano. Now let's move on to Alba Mons. It is located on the northern part of the Tharsis region. At 6.8 kilometers above the datum, it is quite far away in height from the tallest volcanoes on Mars. However, it is the largest volcano surface-wise. If we only count the red region, then it is about 600,000 kilometers square. So it is at least twice the size of Olympus Mons. Alba Mons is also incredibly flat. The elevation rise is so gradual that the average slope is only about 0.5 degrees. Although the surface would look quite rugged in many parts from the on-ground perspective, it wouldn't seem like you are on a mountain at all. This ancient volcano was active between 4 to 3 billion years ago. Afterwards, the activity was gone. This volcano is covered with a layer of dust that is 2 meters thick. Alba Mons also has immense lava flows. Some stretch for hundreds of kilometers, indicating that lava that erupted was highly fluid. The most jarring feature of Alba Mons is the enormous amount of very lengthy fractures. Obviously, they formed due to a great amount of stress on this part of the surface. But what more precisely caused them is still uncertain. These fractures are about 2 to 5 kilometers wide and vary greatly in length. Some are incredibly lengthy, like this fracture here, going in the direction of the North Pole, that is about 1,400 kilometers long. Despite Alba Mons being the largest surface-wise, the most visible central caldera, with all of its sides preserved, is not the biggest on Mars. It is about 60 kilometers across, and it is around a kilometer deep, so it's not very deep either. However, the other, larger caldera, that has only one side preserved, was clearly much bigger. It was at least 100 kilometers long in some directions. The smaller, younger caldera also destroyed the walls of the larger caldera. Now, pretty much all of the mountains, that is, volcanoes, were found in 1971, with the Mariner 9, a NASA spacecraft. It is the first spacecraft to orbit another planet. Later spacecrafts revealed that these volcanoes are the dustiest places on Mars because of their high elevations. The bedrock of these volcanoes is entirely obscured because of a dust layer that is a couple of meters thick. This photo was captured by the NASA spacecraft called Mars Reconnaissance Orbiter. It reached Mars in 2005. This photo is capturing the rim of the smaller caldera on Alba Mons, and in it can be clearly seen a pattern that is created by the wind when there is lots of dust. Now, sadly, the thick dust layer present on these volcanoes make them bad candidates for rovers, as rocks, which are essential for the study of Mars, are much more rare on their surface. So we likely won't be getting photos that are taken directly from the volcanoes. So we also likely won't get to know what it is like to look at the surface of Mars from 14,000 meters above the surface on Elysium Mons. Now, despite that being the case, we might get some other real photos from other mountains in the future rover missions. In fact, we already have something close to that. The NASA Spirit rover that landed on Mars in 2004 managed to climb a 100-meter tall hill called Husband. And in 2005, from the top of the hill, it created an amazing panorama that gave a nice view of nearly the entire crater called Gusev. The crater is about 150 kilometers in diameter. From the top of the Husband Hill, in this panoramic view, you're looking at the rim of the crater that is 75 kilometers away. The identical twin rover of Spirit, called Opportunity, landed on Mars in 2004, just 20 days after Spirit. Opportunity also managed to climb a hill called Cape Tribulation. It is 130 meters above the surrounding plains. And yes, that hill is a part of the rim of the crater called Endeavour, that is 20 kilometers in diameter and 300 meters deep. Nearly 11 years after landing on Mars in 2015, from the top of Cape Tribulation, Opportunity produced this amazing panorama in which the entirety of the 20-kilometer-long crater can be seen. Currently, probably the most impressive look of a mountain from below is from NASA's Curiosity rover that landed on Mars in 2012. It captured this photograph of Mount Sharp that rises about 5 kilometers above the floor of the crater. Now, the top is still 1.5 kilometers above the datum. And yes, this mountain is actually a central peak of the Gale crater that is about 150 kilometers in diameter. The Curiosity rover also started climbing Mount Sharp, and in 2021 it produced this amazing panorama around 400 meters above the floor of the crater. In the distance, you can clearly see the rim of the crater Gale that is around 35 kilometers away. In the meantime, the best we can hope for with regards to future rovers is that at least some of them will be close to the tallest volcanoes on Mars, such that they can still do useful experiments on rocks, but also give us nice views of the enormous volcanoes from below on the ground.